Hey folks, how's it going? So yesterday we looked into the problem called longest palindromic subsequences. So today we're gonna look into substring. So it's still the same question. The difference is that this time we'll look into substring instead of subsequence. So like I said, my goal was to try to make sure that you understand the difference between subsequences as well as substring, because this will help you to know which technique you're supposed to use when you get problems related to subsequence and problem related to substring. So just to kind of like iterate, so we said that the subsequence essentially it's a sequence from the main string that can have gap, but it can maintain the same order. So what I mean by that is that if we have something like ABC, you can essentially say AC. This is valid. So you're still maintaining the order. You can skip B, it's fine. You can have BC, that's okay, right? You can have C, you can have A, something like that. So that's what a subsequence mean. But now with substring, this is where the difference comes in. So essentially it's a sequence right from the main string, but it does not have those gaps. So the sequence has to be contiguous. By that I mean you can't say AC, right? You can't say AC. You skipped B, so this does not make sense. Instead, you can say A, B, C. That's okay. You can say B, C. That's okay. You can say B, A, B. That's okay. You can say A, something like that. So you did not skip any characters as you were extracting these sequences. Does that make sense? So now how do we solve this? Right? The first thing that you will realize is that okay, previously we solved the same problem, and the trick was that with subsequence, we needed to make the decision if we're gonna take a character or no or not, right? So you can say I'm gonna take A, right? You're gonna take A, but I'm gonna skip B. But I can take C, but that path might not be the correct path. Maybe we're supposed to take A and B, that path was going to be the correct path. Something along those lines. But now with substring, we do not have to make that decision, right? So which remove us from like some sort of like a DP solution. We do not have to think along those lines. Here, Rodham, what we can do is that if we are given a string like so, like B A B A D, we just need to extract the substring, right? So we know that this is a valid substring, this is a valid substring, this is a valid substring, this is a valid substring. So we just need to generate those substrings. So how can we do that? So we can say we can have a left and a right pointer, right? And then what we're gonna do is that we can have we can move the right pointer as well as move the left pointer. So when we start, you can think like we we're gonna generate B, then we move the right pointer here, then we generate BA, then we move the right pointer here, then we generate AB, then we remove the right pointer here, then we generate BA, then we remove the right pointer here, then we generate BAD, then the left pointer will come here now, right pointer will go there, then we generate A, right? Then you move the right pointer again, so you're gonna generate AB just like that, right? So that's how you're gonna do it, which means that you're gonna write something like this. You're gonna have for L, which is the left pointer, in length of S, right? Then you're gonna have for R in length of this is going to be range because of you want to also extract the single character, so it's going to be range of L all the way to length of S. Okay, so this code, these double for loops, by the way, they will get you what we're trying to do here, right? So that's what they're going to do. But now we know that we need to check if the string that we extract, something like this, we need to check if this is palindromic, right? We need to check that. So we can think here we have a function that is going to do that for us. So palindromic is going to be easy to write. So if we pass the string, then we're just going to return s equals to the reversed of s, because that's what palindrome mean. It's just a string that you read. It read the same when you have reversed it, right? So like I made an example like a b a. If you reverse this, you bring a here, you bring b here, you bring a here, it's still the same. Like they read the same. But if you take something like a b c, if you reverse this, you bring c here, you bring b here, bring a. They don't read the same. They are not the same. So that's why here this is going to return true. So what you can do here is that you can then check the substring. So you can actually say, okay, S, I'm gonna say from L all the way to R plus one. So this will give you a substring, right? Does this make sense? Then you can take this substring to say that, are you palindromic? You can call that function, are you palindromic? Which we know it has to return true, right? When it returns true, then you can just return, you can keep the length, like which is length is going to be equals to L, um, L, what is it? R minus L plus one. So this is the length of of that substring. Then you can also keep track of, you can also keep this substring if it is greater than the current length that we probably currently have. So I'll write the code for this so that you understand. But the reason I'm explaining quick is because I want you to kind of like have a broad understanding of this, because this is not an efficient solution. This is more like a brute force solution. So how can we let's write the code for this. So coming to the code, this is not an efficient solution, it's a brute force. So we're going to work our way to the most efficient solution. So what we have here is that we're gonna we're gonna generate those substring. The next thing we're gonna check if the generated substring is a palindrome, and it is the best. It is the best, meaning that it is the longest palindrome that we have. So what I'm gonna do is that I'm gonna do what I was doing in the explanation, in which I'm gonna create two pointers, which is gonna be the left and the right, and this is gonna be length of s, as well as I'm gonna say for r in range of so here, because if I want to extract the characters, I'm gonna put L there, so all the way to S. So now what we need to do is that we need to, I'm just going to make the code much more readable, because I want to just define the length once. So the length is going to be R, it's going to be minus L plus 1. So this is how we extract the length, right? So you can think with ABC, ABC. Then if your left is pointing here, your R is pointing the here. So it's like taking R, which is always going to be greater than or equals to L, and minusing it by L, you add plus 1. So you're going to get the length of that substring. I hope that makes sense. So now you extract that substring, you extract the substring itself from the string. So you're gonna say, what is it? It's gonna be L all the way to R plus 1, right? So that's what you have. Now you need to check if the length that you got, it is greater than the best length. So you just have to keep track of the best length. I'm just gonna say best length is equal to 0, as well as maybe we're gonna say best string is gonna be equals to an empty string for now. So if it is, the length that we have is greater than the best length, and actually is also is palindromic, right? If it is palindromic, the subs, then what we want to do is that we want to then say the best length is going to be equals to the length that we have, and the best s is going to be equals to the subs that we just got, the substring. So we just need to define the function called is palindromic. So I hope you saw this. This is actually quite easy, because what you just need to say is that you just need to say is s equals to s reversed. So this is how you kind of like reverse a string in Python. Um, that's that. So we just need to make sure that we return the string, which is going to be best as. So this should work in theory. Um, yes, it does, but it's not efficient. If I try to submit this, you'll see that it's just gonna have the certain cases that it's not gonna work because it's not efficient. It's quadratic. So we need to come up with it worked. But if I submit again, probably it's not gonna work. But you can tell by the milliseconds. But I doubt that in an interview they might accept it. But it's just not gonna. It's not efficient solution. Probably is my network is much faster today. Anyway, let's go back to the whiteboard and try to come up with more efficient and reduce this time complexity. So for us to optimize our code, we need to see some sort of like a pattern that we can leverage in order we can optimize our code and come up with a better algorithm. So we were given this string, right? BA, and I think it was yeah, it was D. So what we did, we tried to generate substring at each character, each position. So if you can think right at this position, we were gonna generate all the substring, right? We can it's gonna be B, then you're gonna come BA, you're gonna come BAB, all the way through, right? And we're gonna come to A and do the same thing, A, B, and all of that, right? But the problem with this is that as you do this, some of the substring that you're going to be generating are not going to be valid, right? And we need to be able to detect that much quicker so that we don't go towards that direction, right? So how can we do that? Like, how can we come up with something better? So we can probably say that how about we say that when we're at like a specific position, we check if our neighbors, if we add our neighbors to us, will they make uh, that substring to be valid, right? To be palindromic, it will that be valid? For instance, we know that B it's valid, so this is fine. So if we then try to increment, we look into the left, we look into the right, we see that okay, this is gonna go out of bound. Probably this is not gonna be valid for us to look at this position from looking at our neighbors. So we can't expand. But now we move our pointer, we bring it here, we repeat the same logic. We say, okay, but A is a valid palindrome, that's fine. We move our pointer to the left, we move our pointer to the right. We say, yeah, this is also valid because if you reverse this, this is going to still be a palindrome. So you're like, okay, BAB, it's valid. You move you move your pointer to the left, you move your pointer to the right. Left is already out of bounds, so you can use that. So you're gonna move your pointer now to this. But the punchline with how we're doing things now is that you can see that when we realize that something is invalid, we move on. We don't have to like continue generate that substring. So which means that this is gonna bring our time complexity to n by n, right? Because of each position, you kind of like move all the way to n. You check like your you check if your neighbors are gonna help you out or not, right? This is much better complexity than what we were doing. But there's still a problem with this solution is that um, we are we are checking for only when like we are checking more like an odd. But what if like we have an even palindrome, for instance? Just trying to come up with a good example, like something like this, maybe. So what will happen with this algorithm that we have currently is that it will come here, but when you go out of when you go and look for your neighbors, you're gonna say, okay, cool, my neighbors left is out of bound and right is valid, but I'm gonna move here because of left is out of bound, right? You're gonna only generate A. But this is a valid palindrome. You see that you're missing it. You're not gonna cater for that, right? Because of you only looking like from an odd perspective. So we need some way to look also like two position at the time. So for instance, if we have A, B, B, A, you can say, okay, I'm going to also start here, also start here. And you can say that my left is going to be here, my right is going to be here. Then this is going to be a valid. Then you can move these position outward, right? That's how you can actually do this, right? And we're gonna write some code to see how this works. So let's do that. Okay, cool. We said that okay, at each position we wanna go outward, right? So this is the position, which is I. So we're gonna say at each position, all the way to the length of s. What we want to do is that we're going to say L equals to ln right. So I'm just going to say ln right equals to I, I. So because of that each character can be is a valid palindrome, so that's why we don't say I plus one and I plus one. We just say I. So and we can move them as we go through the loop. So, like I said, we're gonna say this is odd, whereby we wanna check if L is actually greater than or equals to zero. So it's not, it's still in bound. So it's greater than or equals to zero. And also we wanna make sure that R essentially is gonna be less than the length of S. So this is just to make sure that like as you continue with this while loop, like you're still in bound, right? And then we're gonna check like this is a valid palindrome, right? So you're gonna say SL is equals to I think it's gonna be S, right? If this is the case, what you want to do is that you want to then make your update. Remember that we're looking for the longest. So for you to check the longest, you're gonna say if R minus L, I hope you still remember this formula for checking the length of the current substring. Then if it is greater than res length, so then what we're going to do is that we're going to say result is going to be S starting from L all the way to R plus 1. And then the rest length is going to be equals to R minus L plus 1. Just going to make sure that I define these variables here, which is going to be results, and this is going to be results len equals to 0. Makes sense, right? So we just need to make sure that, because like I said, we're going outward, right? So we need to make sure that left we subtracted and right is gonna be add plus 1. Just to remind you, so we said that if we have something like what is it, BAD, so we said that we're gonna start here at position, then we move left and right. We move left to the left, we move right to the right. So we keep on doing that and we check if like that is gonna help us. It's a valid um, palindrome. So now we have to do this for even. So with even, we just need to make sure that we're pointing to two um, we're pointing to two values, right? Like, so here you can see that we point into the same character. So we just need to make sure that L and right is gonna point to them. The right is gonna point to the next character because we want to point to two. Just to remind you, so we still remember we said that if we had something like A, what is it? B, and A. So you want to point to these two, and you can move outward. So it's just a check to make sure that we are good. So we're gonna say do the same thing. Probably I could have written a function, but lazy, so it's okay. So because we're just gonna rewrite the same code that we just rewritten. So it's gonna be check if these are the same because this is palindrome. Then we're gonna check the length, which is gonna be minus L plus 1. So, and we're gonna check if it's greater than the current length, the current band length that we have, then it's gonna be res equals to s. We're saving this inside here. It's gonna be r plus 1, and this is gonna become our next best length because this is the longest um, substring that we currently have. So we just need to make sure that we move um, left outward, and we move right as well outward. So when we are done, I think we can exit a 10 res. Maybe I have compiler errors. Hopefully not. Let's check. Oh, where is it? Where did I make a mistake? Type error and int. Where did I do this? So I think the problem is with this here. So I was actually sorry about this, and it looks like it works fine. So I'm just gonna submit, and let's check the it works fine. So as you can see that this is way too much better. So I think that the previous solution was like something like 700 or 7,000 or 6,000 milliseconds. So you can see that this solution is way better. So yeah, that's how you kind of like solve this, and you can write an efficient code for this solution. So thanks guys, I really appreciate it. I'll see you guys in the next one. Bye.